The last time that we did any math, we talked about organization of real numbers. Remember, if you remember, went through the sets of numbers like natural, whole, was natural, whole, integer, rational, real, and we talked about how those number systems are set up. And today, what we're talking about is the properties of real numbers. And really, when we're talking about properties of numbers or properties of anything, it's like, what can I do to them that allows them to still stay real numbers, right? They still fit into that real numbers system. Um, and you've used a lot of these properties. A lot of them, they're really intuitive, and you may or may not have heard the titles of these properties, but you guys have been using a lot of them all along. Um, the first one we're going to talk about today is the commutative property. The commutative property is all about order, right? It says that if I have A plus B, it's the same as B plus A. And if you think about that, and that's in terms of addition, right? In multiplication, it would say that if I have A times B, it would equal B times A, right? And if you think about that, it makes sense. Like, you know that if I had 1 plus 2, it would equal the same thing as 2 plus 1, right? I mean, intuitively, you guys already kind of know that just from working with numbers since you were kids, right? And the same thing is true here, is if I had 2 times 3, that's 6, and you know that's the same as 3 times 2, right? Which would also be 6. And so if you think about commutative, it makes sense. Just saying that doesn't matter what order I write these in, the answer is going to be the same, right? And don't confuse this with like order of operations, right? This is just commutative over addition, commutative over multiplication. The next property would be associative. Commutative deals with order. Why are we making this so complicated? It is kind of, Oliver. It is just adding and subtracting. But we're going to move into more complex rules of it. You kind of need to know it as equations get more complex, how they work together. So associative talks about grouping. So associative says if I have A plus B plus C, and these are grouped, it's going to be the same as A plus B plus C if these are grouped, right? What does that mean? It means if I have 1 plus 2 plus 3 and I group these, I would get 1 plus 2 here, 3 plus 3, which would still be 6, right? And here, if I had 1 plus 2 plus 3, same thing. I would have 1 plus this grouping, which is 5, which is still 6. So it's saying commutative says that order doesn't matter. Associative says that grouping doesn't matter. Hey, Oliver, that's not what this chat box is for. Yeah. And the same thing works with multiplication. If I have A times B times C, it's going to equal A times the grouping of B times C. And all of this kind of makes sense, right? With all that. The other properties we're going to talk about are a little newer, and they're things you're going to need down the road. Well, the next one, not so much, but the two after that, inverse and distributive, those will be a little bit newer. But right now, all you have to remember is that commutative deals with order, associative, deals with groupings. The next one is identity. And the identity property is the property that says it's what you do to bring it back to itself. So if I had like A plus something and I needed it to equal that same thing, right? A plus what equals A. What would I add to A to get A back? If it helps to think of it in terms of numbers, what would I add to 2 that would equal 2? Exactly, 0, right? So the identity property with addition is just adding 0 because that's what gives it back to you. What about in terms of multiplication? What would I multiply times A to get A back? 1. Perfect. And so that's all the identity properties are. It's, in this case, I'd have 2 times 1. Oops, and I wrote 2 equals 2. It's whatever I do to get back to that original thing. And where they start getting a little bit more confusing is with inverse. And we're doing the most simple inverse right now. So you'll look at it and you'll go, oh, that makes sense. But really all inverse is, I'm going to write these in blue because I think these are the more important properties to understand. Just write a lame blue line. Inverse is an undoing, is how I like to think of inverse. Man, that's a really thick pen right there. I think of the inverse property as undoing things, right? So, or an opposite. The inverse of something is its opposite. So in terms of addition, if I wanted to find the inverse of A, well, the inverse of A is the opposite of A, which would be negative A, and it would take me back to 0, right? When we're talking about addition, it's what gets us back to 0. So if I had negative 2 is my inverse, and I wanted to get back to 0, in that case, I would add 2 to it. So the inverse of negative 2 would be 2. The inverse of 3c is negative 3c, right? It's whatever takes me back to 0 for addition. For multiplication, it's whatever takes me back to 1. So if I have A and I need to multiply it times something to equal 1, anybody know where that would come from? What I would multiply times A to equal 1? If you think about what we were doing with the addition is we were basically adding its opposite, right? We were adding something, and so we had to subtract, right? We had a positive, we needed a negative, right? We did an opposite. Here we're talking about the inverse with multiplication. What could we multiply times A to equal 1? And the way we do that is we use, well, if we multiplied nothing, that would be 0, right? And that wouldn't work because anything times 0 is just 0. So we couldn't really do nothing. What we'd have to do is multiply it times 1 over itself. Because if you think about fractions and the way they work, if I multiply something times a fraction, that would give me A times 1, which is A, over A, and anything over itself equals 1. So anytime you have a problem, so if I had 4, I would multiply that times 1 over 4, which would give me 4/4, which would give me 1. Does that make some sense? Inverse is a really important concept to get because it's something that we do a lot. Like when you're doing order of operations, you're always using inverse functions. When you're solving for x, what are you looking at? If you remember, say I had like x plus 4 equals 3, and I wanted to solve for x, it means I got to get x all by itself. And what we're doing to x to get it all by itself is we're doing inverse operations on everything that's being done to it. So in this case, the only thing that's happening to x here is it's got 4 added to it. And so I would take the inverse of 4, which is minus 4, and I would subtract it from both sides, and I would get x equals -1. Right? Same thing if I had something times x, if I had 4x equals 3, I have 4 times x, so I'm going to divide both sides by the opposite of multiplication, right? Is division. So I'm going to just divide by that 4 that's being multiplied to it, and I would get x equals 3/4. And I know you guys have solved for equations before. It might have been a while because you guys had geometry since before you had algebra 1, but some of this should look familiar, right? And so that's all we're doing when we do those order of operations. When we're solving for a variable, all we're doing is inverse operations, which is why it's kind of an important property, the fact that we can find these inverses so that we can undo everything that's being done. The last property I want to talk to you about is distributive. You guys have seen distributive in Algebra 1, and you probably used it a bit in geometry. Distributive, I always want to spell it wrong. The distributive one isn't addition or subtraction, it's both together. So if you're seeing a problem that's got a mixture of multiplication and division in the same problem, you see parentheses, it's usually going to be a distributive. But the distributive says if I have A times B plus C, it'll equal A times B plus A times C. And you guys might remember it as like foiling. I never like to use that term, but some people still use it. So if you think of that in terms of if I have, you're multiplying this piece on the outside times each piece, right? You'd go A times B, right? And you would get AB. And then you would go A times C, and you'd go, okay, well, that's plus AC. Do you guys kind of remember that one? So if I had something like 3 times x plus 4, when you distribute, you're going to go to each piece. 3 times x equals 3x, and then 3 times 4 would be plus 12. And if it was 3 times x, oops, look at that. Look at me erasing pieces of important information. This was plus 4. What if this was minus 4? Well, then we go 3 times x, and we'd still get 3x. And when we multiplied 3 times -4, we'd wind up with minus 12. Well, because we're doing it in an equation, it would be minus, but it gives us a -12. Yeah, but they both mean the same thing. You're not wrong in that. And then, yeah, if we needed to solve for x, if we had that equation, if we had 3x minus 12 and we were solving for it, I don't know who put that up there, you would like say it was set equal to 0, then you're going to do the inverse operations to get x by itself, right? You'd add 12 to both sides, right? And you'd have 3x equals 12. And then somebody said that then you would divide by 3, right? This is 3 times x. So if we want to know what x is, we have to do the opposite of multiplication, and we would just divide both sides by 3, and we would have x equals 12 divided by 3, which is 4. So, Shai, you had that one. You got that one. And that's really all we have. Some of your Delta math will be giving you equations and asking you what properties are being used. But again, some of them will ask you things about multiplication over addition of equality, and we didn't go over that stuff because that wasn't supposed to be what this was about, which is why I made the assignment extra credit. So if you get hung up on it, don't sweat it at all. All right. You'll either get 100 points or you'll get partial credit. The Delta Math assignment, if you look at, hold on, let me stop recording because I don't need to see that in the recording.